Hey, it's a do now. What makes the following sums add to zero? So just fill in the blanks for each of those addition problems. What would make the answer zero? Hit pause till you're done. Okay, so solutions negative 29, positive 2x, negative 6x, positive 11. It's just the opposites. Okay, nice job. I knew you'd get that one. So today we're looking at solving equations with x on both sides of the equal sign. Again, we're going to continue to work on this. So let's look at some more difficult problems today. So a couple of examples. Here's number one. What were we going to do if the number at the beginning is not an x number? We've got 29 minus 2x. It's like the constants and the variables traded places. Doesn't actually matter. We're going to do exactly the same thing. So let's get started. I need to find out which side of the equal sign would I like to move the x's to. I can go to the green side, I can go to the blue side. Both totally work. Your choice. Which one you want to do? Well, I don't know what you just said, but here's what I'm going to do. I don't like negative numbers. And I can see if I look at the next step, if I were to get rid of this blue 6x, I'd have to subtract 6x. And when I subtract 6x on the other side, I got a negative 2x. I subtract more, it's going to give me a negative number. And I would rather not deal with negative numbers if I don't have to. Totally possible, no problem. But I'd rather not. So I'm going to add 2x to both sides to get rid of this green negative 2x because I don't want negative numbers. Okay, so on the green side, individual pencils, 29, that does not change. Didn't do anything to that. Negative 2x plus 2x, those are going to add to make 0. So I got nothing in the x column, no boxes. On the other side of the equal sign, I had 6x. I added 2x. It's going to give me a total of 8x. And in the pencil column, the constants, I had negative 11. Nothing changed there. So here is my, oh no, I am missing an equal sign. Here's my next line. So since I chose to move the x's to the right-hand side or the blue side, I'm going to work next to get rid of all the other numbers from the blue side. So only x is left. And that means I'm going to get rid of the constants. So if I had minus 11 or negative 11, the opposite of that would be to add 11 on both sides. Next line. I know that the negative 11 and positive 11 are going to cancel. I'll write that down ahead of time. And then over here, I got 29 plus 11. That's going to give me 40. Equal sign comes straight down. 8x is unchanged. And in that last column of constants, there's nothing. I could write a 0, but I don't think that's going to be helpful. So I'll just leave it blank. Last step, trying to get x by itself. I need this 8 to get knocked off of there. So I'll have to divide both sides by 8 since the 8 was being multiplied onto the x. The opposite multiply is divide. Divide by 8. So I know that 8 divided by 8 is going to give me 1x. I'm not going to write the 1, but I know that there's a 1 there. Let's go straight down each column. 40 divided by 8 is 5. Equal sign comes straight down, and this will be just an x. So my solution is 5 equals x, or x equals 5. Nice. So let's revisit what we just saw in the do now, because those numbers all showed up in this problem. So the opposite of positive 29 is negative 29. The opposite of 6x is negative 6x, negative 2x, the opposite of 2x, negative 11, the opposite of 11. Any one of those four things could have been our first step in this problem. Those are all the same numbers that we see right here. We got a positive 29, the negative 2x, the positive 6x, the negative 11. We could have chosen as our first step any one of those four different terms to cancel. I'm not sure that they're all the best idea, but we could have done it and we would have got the same answer. It would not be an incorrect thing to do. We could have chosen as our first step to cancel the 29. That'd be fine. You subtract 29 on both sides. We did, in fact, cancel the negative 2x. I mentioned already we could have, instead of that, canceled the 6x by subtracting 6x. I didn't want to do that because I don't like negative numbers, but it's an option. And we also, as the last option, could have canceled the negative 11. Um, any of those would have been fine as the first step. I always recommend working with the x's first. There's a good reason for that. We'll see that tomorrow. And if it's possible, I say avoid negative numbers, because why introduce extra difficulties to our problem if we don't have to have those negative numbers there? All right. Now let's look at one more example. What about an even harder one? Here it is. An even more challenging, wasn't that challenging, but more challenging than the last problem. So I got 7, I got parentheses, we got distribution. We have to multiply the 7 times the set of parentheses, x minus 4, and that equals 2x plus 17. This doesn't fit my format. I'm going to keep the columns. I still got boxes, or that's where the x terms will go, and individual pencils, that's where the constants will go. I've got those labeled on both sides. But these parentheses don't really fit because, well, I mean, they don't fit. That's just a question of fitting, really. So we do have two options. One option is we could reverse the distribution. Instead of multiplying the 7 into the parentheses, we could say, look, that does mean multiply. The opposite would be to divide. I could cancel the 7, but I can see on the green side, neither of those numbers is going to divide evenly by 7. So I'm going to be stuck with like fractions or decimals. I'm not a big fan there if I don't have to do that. So I think the best option is going to be to multiply that 7 onto the x and onto that negative 4. So that will give me 7 times x is 7x. 7 times negative 4 is negative 28. Whew, now everything fits nicely in its column. I like that better. Equal sign comes down, 2x here, plus 17 over there. Okay. So we got everything lined up. Now it's ready to just do our work. So I'm going to move the x's to one side or the other. I could choose to subtract 7x from the red side, so I end up with no x's there, but that would give me negative when I subtract 7x from the other side. So I don't want to do that. Here's the option I think is best. I'm going to subtract 2x. Always start with the x's. So we subtract, and the 2x, positive 2x, and the negative 2x, those are going to give me 0. I'm just going to leave it as a blank. Okay, let's go down each column. 7x minus 2x. It's going to give me 5x. This minus 28, I didn't do anything to that. It's still the same. Equal sign comes straight down. In this column, I'm going to leave that blank. I got no x's left. And then 17. I don't need the plus anymore because if I just write 17, it still means positive 17. Next step. Get rid of the numbers. I want to get the x by itself, so I want these constants to go away. Add 28. Do the same thing on the other side. Keep it lined up in the constant column. Numbers go with numbers. We don't get confused with x's and constants and stuff, getting mixed up in the wrong columns. Okay, so the first column, 5x, that comes straight down. Second column, negative 28, positive 28 is 0. I'm going to leave it blank. Equal sign. And then the blank column already is going to stay blank. And 17 plus 28, that's what, 45. My 5's missing its lid. Okay, last step to get the x by itself is to get rid of that 5 in front of the x. It's being multiplied onto the x, so that means to undo it, I'll have to divide. And 5 divided by 5 is going to give me just 1x. So let's get a separation of our workspace. X equals, and 45 divided by 5 is 9. There's my solution. Let's put some stars on that. X equals 9. Okay, so what just happened is it's afterwards, let's summarize. We had a problem that did not fit into our columns with x's and constants, so we distributed. Everything after that was the same thing we've seen before.